Hi, everyone. Professor Hosmer here, just getting set up here and getting started. Welcome to week 15. Got a couple of weeks left to do week 15 in your final project. So I want to kind of jump right into it this week and kind of go. Can you guys see my screen and hear me okay? Just want to make sure we're.
Yeah, no problem.
Great. Thank you. Thank you. All right. So did anybody have any problems with the virus total example in the assignment from last week? If not, I won't even bother going over it because it was pretty straightforward, but I'm happy to do it. I actually have it there if anybody wants to see the solution. It was mostly basically processing files and, doing that. So I will post it tomorrow for you so that if you had any difficulties with it, you can step through it. Obviously, you have to put in your own key. But if you want to go over it, I will. It's pretty straightforward, but it's. Okay. All right, let's talk about this little introduction to data science with Python that I put together. Because it's kind of a prelude to the next course in the sequence if you're interested in doing that. So let me actually walk through the brief, and if you have second thoughts on the virus total thing, we can still jump in to it. Okay, so let's talk a little bit about data science in general. Because when you think about data science, it encompasses a lot of different things, and data science and AI and a bunch of things are typically misused and typically not described correctly. Everybody kind of is pretty loose with these definitions and how they work and that kind of stuff. So let's see if we can cover that. So I want to clear up the confusion a little bit for you, just as kind of an introduction. Clear up the confusion between AI and data science and machine learning and deep learning and expert systems, heuristics, neural nets, decision engines, smart cars, smart medicine, smart appliances, along with many other commonly used terms that are often misused. I'm not going to cover all of those tonight. I'm just going to kind of give you a quick introduction to at least solidify a couple of the basic definitions, and then we'll talk a little bit about machine learning tonight. So what is artificial intelligence, and how do we actually define that in the simplest terms that we can? AI, or artificial intelligence, is the development of machines that can think and act like humans. That's the simplest definition out there of what artificial intelligence is, right? It kind of makes sense. We're basically programming a machine, a computer, whatever you want to call it, that can think and then act like humans. And there's some really good tests for determining how well we do that. The most famous one is the Turing test, named after Alan Turing, who asked that kind of really provocative question back in the 1950s, and that was, can computers think? And we've kind of advanced that. So that's the basic definition of artificial intelligence. And there's many different aspects of that. Some of them on the previous slide, talking about machine learning and expert systems and deep learning and neural net, all kind of fall under that umbrella. Those are methods that we use to invoke or provide some level of artificial intelligence. So then what is data science then? If that's artificial intelligence, so what in fact is data science? Well, it's the study of data, which makes sense. That includes mining, exploring, validating, visualizing, and modeling in order to extract useful information and meaningful insights. So when you think about that, the first one might kind of boggle your mind. What do you mean mining? Well, typically when we're performing data science, first thing we need is data. So we have to go get it, and we have to explore it. We have to validate it, because typically it's awful, and we have to do all kinds of work in order to get it into a shape that we could actually do things like visualize it and then create models from that, and then be able to potentially extract some useful information and meaningful insights, and use that those models in order to be able to perform some level of artificial intelligence, whether it's machine learning or something else. So the general process then of data science is we mine the data from a variety of sources that we can obtain that data, typically the internet or databases that have been created. And like I said, in most cases, those databases and data sets that are out there have some level of flaw in them. They may not be consistent, they may not be complete. They have data that is just invalid, and we have to do a lot in that process to explore the data that we've mined. And then from that, we can actually model some of that data in several different ways, and then actually visualize it. And we use a variety of tools to visualize that data. And the reason that we visualize it, when we model the data, we may look at it in table form, a tabular form. But we also may visualize it using a variety of tools that allow us to look at the data in graphs and charts to see how it lines up. And then we apply in that process statistics and other mechanisms in order to be able to bring out information from that data, the standard mean, standard deviations, those kinds of things that we'll use on the data. One of the things that you should know is that when we model this data from a data science perspective, it's all needs to be in the form of numbers. So even if we're modeling text, we have to convert the text into some sort of numeric values within our table so we can visualize that. Then we need to validate it. In other words, after we do the visualization, we may see issues with it, and we have to go back and do more exploration and more mining of that data. And then we finally, when we get to the point where we're pretty comfortable with the data that we have, we can put it into practice. So what can we do with it? Well, there are applications in speech recognition and in transportation, live assistants that you guys probably are familiar with, Google or Siri or Alexa, those kinds of live assistants that we can interact with. Object identification, so we can identify objects within visual areas, and then certainly a whole plethora of applications within healthcare of the data that we have that can help us define disease and develop new cures and those kinds of things. So those are some of the things that we can do with data once we've actually performed this data science operation. We can start to apply that data based on the domain to those particular areas. So one of the reasons that we talk about this from a Python point of view, because the Python ecosystem for data science and even machine learning is quite rich. And obviously it's relatively easy to learn, platform independent, just like all of the other things we've learned about Python up to this point, and it's community supported. But the real reason is there's extensive libraries that are available to us in order to be able to utilize the data that we're creating in order to be able to do it. And those things like NumPy and SciPy and Pandas, all words that you may or may not be familiar with, scikit-learn and NLTK, which you're a little bit familiar with because you've used the natural language toolkit. It kind of falls into that ecosystem within Python. And it's all there for us to do. We can visualize it, and then we can actually use it to perform machine learning operations. So some of the key libraries, and I'm just going to touch on some of these tonight to kind of give you this introduction, are things like NumPy and SciPy and Matplot and Pandas and scikit-learn. Those are the core libraries that are part of the ecosystem. And there's many more like PyTorch and TensorFlow, which is a neural net kind of environment that allows us to do more deep learning activities from that perspective. So there's a variety of libraries that are available to us, so we don't have to build this from scratch. So what's NumPy? One of the core libraries that are used not only independently, but also by pretty much all of the other libraries that I mentioned. And so NumPy, again, is one of the core Python packages for scientific computing. It's mainly used when we're creating arrays, typically multi-dimensional arrays, where we can then apply advanced mathematical processing and statistics, those kinds of things. This greatly improves the performance of things like linear algebra and Fourier transforms that we basically use. Now, we typically don't have to necessarily perform the mathematical operations because they've been performed for us, and we're going to use those based on the other libraries. Like I said, NumPy is integrated into those other libraries. So what can we do? So we can create an array with NumPy and put a bunch of numbers in it, and then we can convert all of those numbers to integers with one line of code. So instead of actually having to iterate, through the array or through a list, there are a whole set of functions that are associated with NumPy that allow us to perform things like this, where we can convert all of the numbers in one line of code to integers. Kind of very simple, but just kind of give the idea. There's a whole set of functions that are available to us that we can operate in this. We want to calculate the standard deviation, or we want to calculate, other mathematical operations on the array. We can do most of those with a single line of code. You notice that I said import NumPy as NP. And the reason we do that is because it just shortens what we have to do when we're trying to access the functions within the NumPy library. And when you're looking on the internet and you'll see everybody uses this nomenclature. So we can basically see, when you're looking at that, you're going to see NP dot. So then what's SciPy? What is that all about? And what does that library perform for us? It's another Python library that's used, again, for scientific computing. One of its key capabilities, however, is the ability to convert large arrays into sparse matrices. For example, if I have an array that's been created from some data that we have, and there's a bunch of values in this particular array that are 0, that have basically no potential value. Again, I can use SciPy in order to be able to parse, create a sparse matrices of these hue angles, and then print them out. And you notice what it does is it converts those rows and columns, and it eliminates all those values that are 0. So basically for row 0, there's just one value now, 1.8, then 1.5, 1.1, 1.4. That's all that's actually in the array that's meaningful. So we can reduce this down, which allows us to do some processing, on that data in a more meaningful way. So what's Matplot then? It's the primary scientific plotting library that we use, but there's also another library called Seaborn that I won't go into, which gives us even some more interesting plots. But Seaborn uses Matplot library in its processing, so we can create things like heat maps and pair plots and a bunch of really cool things. But Matplot is the underpinning that allows us to do this, and the library provides for the kind of the visualization of these matrices that I've showed you, or histograms or scatter plots. We can generate all of these, again, typically with 1 or 2 lines of code, so that we can get a way to visualize the data that we're looking for. So I can take that NumPy array that we had initially, and then I can, in a single line of code here, I can say plot the hue angles. So it's going to basically take that array of hue angles and it's going to plot them, and I can actually take a look at what they look like. And all kinds of parameterization that we can do to make the charts even prettier. But just to give you an idea of how easy it is to be able to use the Python ecosystem to do things like this once we get our data in a particular form that we're interested in using. So one of the really important libraries within the Python ecosystem is something called pandas. And pandas are basically short for panel data. Think of it as a spreadsheet that we can actually manipulate right within Python code. So we can do things like filter the data, we can analyze the data, we can scrub it, we can validate it. We can do all kinds of manipulation of this spreadsheet. So think of the data that we're talking about, the arrays that we have. And if I want to bring it into this spreadsheet kind of function, remember these arrays and tables can be very large. And I may want to be able to perform some processing on a portion of the table. I may want to rearrange the table. I may want to be able to pull parts of the table out and use it to perform some operation. And we use pandas in order to be able to do that. So, for example, I can take that original, this hue variance, and basically say, hey, I want to convert that into 4 columns in hue variation, the location, which column it was in. I can basically start to build tables that are more familiar to us, maybe than arrays, in order to be able to process that information. And we go into this in great detail in CYBV 474 and how to use these and apply these in the area. So now let's get to the point where, what are we going to do with all this? What's the point of this and how do we use it? Again, one of the core ecosystem libraries within Python is something called scikit-learn. It's a very powerful and very well used library within the Python ecosystem for machine learning. And it provides a whole set of core functions that we can use. Once we have data that we want to actually use to train a model, we can actually use scikit-learn to do that. Scikit provides both supervised and unsupervised learning algorithms. It can leverage libraries that we have already covered, NumPy and Pandas and Matplotlib. The key machine learning algorithms that scikit provide include things like regression, including linear and logistic. But also what we typically use it for is classification. When you think about classification, you think about being able to take data. Let's say we have a whole set of news stories. They're labeled. We have some that are labeled as real or fake. We can use the classification model in order to be able to take that data and train the model to give us an answer, to predict. If I train it on a set of data that's been labeled, like let's say real or fake news, or tweets that were either hostile or benign, those kinds of things, we can basically use the classification functions and modules within scikit-learn to basically then feed it new data. And based on what we've trained it with, the model, it can basically give us a prediction of whether this new news story that we have, or this new tweet that we've provided it, whether it was real or fake or hostile or benign. We can do that once we've actually trained the model. And once we've done that, we can actually update the model with more data to get more accuracy. So that's one of the modules that we use most, within scikit-learn, is this concept of classification. And there's also clustering and some other things that we can do as well in very specialized situations. But the classification area of scikit-learn is something that we use, quite often to answer those basic questions. Now, one of the things I should mention is that from a machine learning perspective, the results that we produce are probabilistic. Unlike if we were using an expert system that is rule-based, that we have rules that define certain decisions they're going to make, those are deterministic. Based on this input, we're going to take this output. But in the case of machine learning, the results we're going to get are probabilistic. So we have a set of data that we've trained the model on, and now we're going to use that data to predict this new entry into the system to see where it falls. And so we end up with a probabilistic result, something that, hey, this is a likely fake news story, or this is a likely hostile tweet, or this is a likely fake image that we're dealing with. So again, the work that we do here when we're actually building the model all comes down to something that we call feature selection. And we're looking at the data that we actually want to process and model and create panel data from, and plot that data. We have to select features from the data that we have that are going to be meaningful. And this process tends to be iterative. We'll select some features, we'll build some panel data, we'll plot it, and then we'll run the model and we'll say, wow, I didn't get very good results there. My accuracy is only 50 or 60%. I can do almost as good with a flip of the coin. So we continue to modify the features that we select in order to be able to build better and better models. And once we do that, we can then kind of move to the next level. So just want to kind of make a definition of what the difference between supervised and unsupervised machine learning is. So from a supervised perspective, think of it as a way of predicting a certain classification or output when we're given labeled examples of the data that fit into, let's say, a specific classification. A model that has been trained using a broad range of samples, or a never seen before input outside the training set, can be evaluated. So that's basically what supervised learning is. Think about it as, hey, this is the known. We know these examples that we have fit into these classifications. And so now we can actually train a model based on that supervision that we're giving to the model. Unsupervised learning is quite different. There's no predetermined output. There's no guide or teacher like there was on the supervised side, and only input data is provided and selected features, for example. And so the algorithm is then asked to extract knowledge from the data. Tell me what data within this particular model, into this data, is meaningful, and how do they relate with each other? And then we can use that information in order to be able to, again, make prediction, but from a different point of view. So what kind of examples can we glean from this? From a cyber or forensic point of view, what can we do? Well, we can obviously process natural language and perform text processing to extract meaning from, let's say, language. We can do things like photo identification. We can differentiate between real and fake news, for example. We can filter spam. So in other words, if we get an email message that contains data, we can analyze that and basically put it into the spam or ham bucket and say, this is spam versus this is fine. We can do fake photo identification. So we can use it to determine if a particular photograph had been altered in some way to basically present something different. We can even use it for malware identification. So we can use and collect features from an executable and determine whether that those features tend to indicate this particular piece of software is malicious or not. We can do things like network behavior analysis. So we can, again, train the machine learning engine with, quote, normal behavior and collect features from that network when it's operating under normal conditions, and then be able to detect, use the model to feed, here's what I'm seeing right now, and how does that fit from a classification perspective with what we trained the model with. And obviously we can do the same thing with user behavior analysis. So in other words, basically users perform operations in a certain way. We can model that and then be able to detect behaviors that are anomalous or aberrant from what they would normally do. And then you could use that information to predict, hey, something is different here, and maybe it's not the right user, or maybe the user has changed behavior from some ways that we need to identify. So this all kind of leads to the next course in the sequence, which is CYBV 474, which is Advanced Analytics for Security Operations. And we provide the students with a kind of a very in-depth hands-on experience applying Python along with key AI methods that you've kind of brushed on a little bit with NLP and natural language processing, but we start to integrate things like machine learning methods, expert decision-making, and apply those to real-world cybersecurity challenges. And so that's what Cyber 474 is about. Is to apply these methods and from using the Python ecosystem in order to be able to make these kinds of predictions and classifications of data that we're going to be able to process, but applied to specific challenges that we're concerned about within cybersecurity or forensics or incident response or open source intelligence, that kind of thing. So the only other thing we're going to talk about tonight is your final scripting project. Your final scripting project is going to use the VLE in Cyberopolis to scrape the CASL website. We've already done this earlier in the semester, but we're going to take that example to the next level. Couple important notes when you're scraping that entire website. Make sure you do not outside Cyberopolis. And you're only allowed to use standard Python libraries and any third-party libraries that we've used during the course. Obviously, you're going to need the natural language toolkit and that kind of stuff to do that. So all of those are fair game. Your script's going to generate a report that contains the following info. You're going to identify any unique URLs of all the pages found on the website. So any URLs that you find, any URLs that link to images that are found on the website. You're going to extract phone numbers found on the website, extract text content from each of the pages and store them in a string variable. So basically, you're going to be using NLTK in order to be able to do some of this work and extract zip codes from the pages. A note for items 6 through 8, you'll be using NLTK to process all the text that was found on the website using the text content that you extracted during item 4 above. You're going to list all the unique vocabulary, focus on unique vocabulary that was found on the website, list all the possible verbs and all the possible nouns. So all of that is possible from using NLTK to do that. So you're going to do some collection at the beginning to collect some information. And then at the bottom, you're going to take that text content that you've extracted from each of the pages, and you're going to basically extract some more specific information, vocabulary, verbs, nouns from that. You're just going to submit your Python script and the full output of your script that's going to include all of these items that you collected 1 through 8 to do that. And that's the rest of the course. The good news is you have a couple weeks to do that, because this is not due till the 4th of May. And the only thing that's due next week is your quiz. That is basically a review of what I just presented you regarding data science and machine learning and that kind of thing. So that should be fairly straightforward to do. So I have enabled week 15, which has all of the information that we're doing today. And then for the final, that's in the slide deck, but I'll enable that now for you. So all of that's here as well. And I've provided you with the pattern matching for regular expressions for the zip code and phone numbers. And you have the ones for URL from the previous assignments that I had provided you with. Actually, you'll get those from the actual scraping of the website. So all of those are there. Again, this assignment is due on May 4th. It's not due next week. You have 2 weeks to actually work on this. So I would start, the process. And the advice here is to kind of take this in a stepwise fashion. First, make sure that you know how to basically extract all the pages from the website, and then start, with the URLs of the pages, of all the URLs that are found on the pages, and then do the images. So kind of do this in a stepwise function, kind of keeping track of each of the things that you're doing. None of this is really super hard, but it requires a little bit of organization to actually walk through that process. Exactly, John. Maybe the 4th be with you. That's a good one. So you'll be all done on the 4th. So then the 5th is Cinco de Mayo. So then you can do whatever you do on that great day. Have some fun with this. A question came up during the office hour this week, whether or not I'm going to be doing any other lectures. And I don't plan on it, but I will do the office hours on each of the Tuesdays. This coming Tuesday and then the following Tuesday, I'll have office hours. So if you do have questions, I'm not going to solve the assignment for you, but certainly if you have questions regarding Python or some of the basic things that you have to do for this and processing the regular expression or, extracting data from a website, that kind of stuff. If any of those things are still unclear to you, bring those to the office hours next Tuesday and the following Tuesday, and I'll be happy to try to answer some of those questions, do that. But think about, before you even try to jump in and do this, review the previous assignment that kind of did some of the scraping, and then kind of lay out on a piece of paper, the steps that you're going to take. And that I will review. So in other words, if you're concerned that you don't have the process or the flow down, you can bring that up during the office hours, and I'd be happy to take a look at that and give you any advice on how to approach the problem that you need to take in order to be able to do it.
Hi, Professor. This is Giselle. I have a quick question on the final project on number 3. It says extract and phone numbers.
Oh yeah, that's a problem. I should say extract.
Is anything else that we need to extract on number 3, or just the phone numbers?
Yeah, it's just extract phone numbers found on the website.
Oh, perfect. Okay.
Thank you for putting that out, though.
No, I just wanted to make sure so I wouldn't miss anything. Thank you so much.
You're welcome. Steve, I'll take a look at the the syllabus, to see why there's a difference there, but I think we've accomplished. I know that the grade book is right, so let me just double check the assignment. Yeah, there are only 19, and those are the ones that are in the grade book. So probably 19 and then 20 was the final project. I don't know why it said 22. I'll have to fix the syllabus. So, but don't worry about it. The grade book is right, and these are all the assignments that are there. But I will go back and make that edit to the syllabus. Thank you. Any other questions? So like I said, I'll be around for the next couple of weeks to help you through this, and emails, whatever, come to the office hours. Be happy to do that. I'm still running the Saturday sessions. So you have 2 Saturday sessions and 2 office hours as well, that you're welcome to come and ask questions, and hope you've enjoyed the class, and hopefully this assignment is not that difficult. I think you can all do it based on what I've seen you guys doing recently. I think you guys have a really good handle on this, but again, myself and Elizabeth are here to help. Any Pythonic issues that you might have, we'll be happy to do that. Any questions or any comments generally on the course, or where you think we are, and anybody have any anxiety going forward with the final project?
got one brief
Enjoyed the
question.
course so far. Thank you very much.
Okay, great, guys. Well, listen, have like I said, remember the 2 Saturday sessions, the 2 office hour sessions, and obviously we're always looking at your emails. And if you have any questions, don't hesitate to ask. Elizabeth and I are both here to do that. And enjoy the rest of your time for this course and the rest of the semester, and look forward to reviewing your final project. I think I only have one. The virus total, I'm pretty much caught up on the assignment grading. So that should be said, but I will go back and look if there was an assignment that you missed and didn't complete. I will still grade those. So just make sure that you post those before the 4th, and I will take a look at those from that perspective. I take off some points for being late, but you don't want to get 0. So just keep that in mind. If you had struggled with something, want to go back and complete it, please do that. Okay. All right. Have a great day, everybody. Take care and be safe. And we'll look forward to seeing you in the next couple of weeks during the office hours. Take care.